video goes along with number 41 from the final review packet. We have a little bit of information given to us about cotangent of theta. We're going to try to find sine of theta. We need a diagram. So remember, cotangent is the reciprocal of tangent. So instead of opposite over adjacent, this is adjacent over opposite. Now, let me write something on here, because what could be going on, and we have to figure this out, is that negative could belong with either the 8 or the 15. It could never belong with the hypotenuse because that's always positive, but could be in either case. So here's how we'll determine where that negative goes. If we're in quadrant 2, let's think about sketching an angle in quadrant 2. If our adjacent is the horizontal, that's the one that's going to get the negative, and then the 15 will be the positive. Okay, so this is really the one that we're working with, but it could, in other examples in other quadrants, have been a negative opposite side. Okay, so that's what we have. We are going to try to figure out not really even what theta is, just sine of theta. So to find sine of theta, I just need opposite over hypotenuse. I already have, let me label here, here's my adjacent, here's my opposite. Let's just find the hypotenuse and plug it into our little SOHCAHTOA ratio. This is just a little Pythagorean theorem problem. So 8 squared, negative 8 squared, plus 15 squared equals, I'll just call it r squared. That is a triple if you know it. That side length, or you solve it, is just 17. So let's plug in back over here. Opposite over hypotenuse is just 15/17. Notice we didn't actually even have to find the angle. You could use some inverse trig functions and figure out what theta is and then just plug it in here, but you probably won't get that nice exact value, but it could be close.